Hey guys, in this video we're going to be checking out a 2-in-1 3D printer by a company called Tevoup. And what makes the Hydra model unique is the interchangeable tool heads from 3D printing to a laser. So in this video we're going to unbox it, set it up, burn some things, and do some prints. So hopefully you guys enjoyed the video. Let's get started. Alright, so yeah, this is the box that the Hydra comes in. We can see here a picture of what the printer looks like. And here on one of the sides, we got some more information. The build volume, which is 310 by 310 by 400, very nice. Layer resolution, supported filaments up to 280C. Get a 0.4 nozzle. Product dimensions in millimeters and inches. On the shipping label, it says 14 kilograms, which is about 30 pounds. So let's go ahead and open it up. So as we open it, we can see we got black soft foam. And this is what we see right on top. We got the manual, and it's a book, which is really nice. Seems to be laid out pretty well. Everything that's included, all the technical parameters, and the assembly process, which should be very simple. We're just gonna connect the gantry to the base. So yeah, it looks like a really good manual, very nicely laid out, and shouldn't be too hard to get going. So first thing that really stands out are these heads. So we got the laser, and it looks like there's a piece to it that we need to install. Well, actually, it looks magnetic. Let's see. Okay, yeah, it is magnetic. Oh, very cool. So yeah, this is the laser. Looks like we got a little protector there over the lens. So I'm not too sure what the power rating of this thing is, but I think it's in the manual. We just need to look it up. But yeah, very nicely made. This is all metal, and you guys can see the laser modules encased inside. Very cool little logo here up front. And then we got this cap that just clips over and magnetizes. And on the back, we have a connection, which is made out of aluminum. Very nice, high quality parts here. And here we can see the connectors, and they do give you a little warning there saying, make sure the power's off before you change the module. So yeah, very cool. So our print head will have the similar kind of back with the quick disconnect. We do have a dual gear drive extruder. Very nice. This is our heat break. It's round style. And then the heat block below that with a silicone sock. And man, that's a tiny little hole for the nozzle. So over here we have the heat break cooling fan that blows onto here. And then going here we can see the logo, very cool. And again, this is an aluminum little cover here. Extruder motor, and below that the parts cooling fan, which is the large one. And we have a 3D printed duct that blows over the nozzle, and it's a little bit higher and blows more towards here. So I guess we'll see how well the cooling is. But overall, very nice piece, nicely built, and feels really high quality. Alright, so now that we got that out of the way, let's go ahead and see what else we got. Here we have a couple parts that look like to be part of the frame of a spool holder. Safety glasses, and this is for the laser. Keep your eyes safe. We got a pouch here of all kinds of stuff, and we'll go through this here in a second, guys. A little coil of filament, not too crazy about this. It is in white PLA, and it's something to get you started. A USB cable to connect from the printer to the computer. A spatula that's not sharpened. Our power cable, US type, and does not look that long. But yeah, that's all the pieces here on top. Alright, so here we have a little wood plank. I'm guessing this is probably to do some laser burning. So they do include a little thin piece of wood that you can practice on. And for the last part, looks like we have an extra ribbon cable. That's probably a spare. Alright, so we got the gantry on top of the base, and you guys can see everything's packed very well, even though the box is pretty small for this size printer. Alright, so here we have the upper portion of the printer, which is the gantry, and you guys can see connector plate where the tools will be interchanged. So it looks like our belt is loose, so we're going to need to do some adjustments here. No big deal. And if we flip it around, we got dual Z axes, really nice. But what's even nicer is that they are tethered here on the top with this belt. But yeah, we'll take a closer look at everything a little bit later in the video. All right. So here we have appears to be a steel sheet that's quite thin, and it is the size of the build plate. So I'm wondering if this is for using to cover the build plate to protect it from when you're using the laser. And that'd probably be my guess. It would make sense. And this is a coating here that does peel, and you got like a nice finish there. So all right, so we're finally at the bottom, and we got the base here. It is pretty large and quite heavy. And yeah, the first thing that really stands out is the design. Very interesting looking and quite modern. And what's really impressive is this shell here is one piece metal. So again, we're going to take a closer look at everything a little bit later. Let's go ahead and get this out of the way. And that's everything for the box. All right, so I got the base flipped around, and before we start assembling, I want to go ahead and take this cover off. Looks like it does come off here with about 8 little bolts. So let's go ahead and grab this little bag and see what's inside. So we do have some tools, Allen wrenches, zip ties, clean out needle, and an open-ended wrench. Some clips looks like to hold the sheet, and a glue stick. 4 pretty large bolts, and these are for connecting the gantry to the base. Looks like a bunch of spare parts like bearings and bolts, T-nuts, just things like that. Also spare parts, 3 roller wheels, and a nozzle 0.4 size. And in this baggie we have a filament detector and a USB thumb drive that has the Tevoup logo on it. And for the last part, we got a large Allen wrench. And yeah, pretty cool that they include a little bag, pull all the stuff in. So let's grab the wrench that we need and take out these 8 bolts. Well guys, there's actually 10 bolts here. And now this should just come right off. Let's see. Okay. And we do have a pretty large fan connected to it. I'm just gonna set it here just like that. And yeah, wow, this is a very nice, clean design. Very impressed with how everything is routed and neatly organized. So let's start here with the main board. You guys can see we have a maker base MKS Robin Nano version 3.0. We do have removable stepper drivers. Go ahead and pull one off. I can't really make out the model number, but I did see it says Germany on them. So yeah, look like really nice high quality parts, and they are heat sinked. Oh, very cool. Got a pretty interesting chip there, maybe Wi-Fi. Our USB cables running from the board to the ports, and there's like this film foil that runs from there to here, which is quite interesting. So yeah, you guys can see the wires are all organized very nicely. So that's our touchscreen. And going this way, I like the attention to detail with all this covers here around the wires. Looks like another junction there. And then these wires lead to the power supply, which is not very large. And the reason for that is because we have an AC heated bed. So that is a solid state relay that takes the mains power and sends it to the bed, which is really awesome because this build plate of this size should heat up relatively quick. But the power supply is a 240 watt, 24 volt. And yeah, again, wires are all very nicely organized. So this is our mains input here. We do have an on and off switch, and it is fused, our Y-axis motor. And also guys, if you can see here, we have bracing on the inside that's kind of like a box that gives this thing even more rigidity, even though the whole base is completely metal. So yeah, lots of high quality and great design for strength, and just very well put together. So let's go ahead and put this lid back on, and you guys can see we got a couple cutouts here, and this is where our bolts will go through to connect the gantry. And we also do have 5 little rubber feet that the printer sits on. All right, so I'm going to put this thing back and we'll flip it around and start the assembly. So for the next part, what I like to do is go ahead and look at the bed, the rollers underneath, and check if it's loose or not, because it is a little bit easier to do it now than later when you have the gantry on, and it's kind of harder to move it around. But you guys can see we got 3 rollers here on one side and 3 on the other. And what's interesting about this printer, I'll flip it to the other side, is that they are all adjustable. So they all have eccentric nuts. Now what I like to do is stick my fingers under there. So just kind of hold the bed and try to spin the roller. It's kind of deep in there. You might not be able to reach it that easy. But so on mine here, these 2 are good, and the one here up front completely loose. So the whole point is you want to squeeze around the channel just slightly on all the rollers. So as loose as possible without being wobbly. And our bed is practically not wobbly, but we do need to tighten up that front wheel, and we're going to use the included open-ended wrench. It's a little hard to see and even get to, but yeah, we're just going to spin the eccentric nut just a little bit, try to tighten it up to get closer to the rail, and same thing on the other side. All right, so I think I'm getting somewhere here. Front wheels are touching, and my other wheels all seem to be okay. So yeah, that feels pretty good right there. And so you can run it back and forth to see, make sure you're pretty good and smooth. So if you feel something really, sticking or grabbing, then, keep on adjusting and checking everything. All right, so let's go ahead and look at the manual here. So the first thing we're gonna do is install the gantry, which should be pretty simple. 4 long bolts that go underneath through the base. And you guys can see here, there's an opening here and on the other side. Now there is a connection here to the ribbon cable that we'll have to connect. So yeah, we'll have to be careful with that. So let's go ahead and put the upper portion of the printer onto the base, and it should just line up and fall in. And there it goes. So once it falls in, it kind of holds itself somewhat. We'll need these long bolts, and they do come with lock washers, so we'll put them in there. Let's grab the wrench we need for these bolts, and what you can do is just lift it with your hand, or maybe, put something underneath the printer. So that would be enough to start them, but it would be a little hard to get the wrench under there, so we need to go higher. Or maybe this way would be easier, yeah. Or you can just go off the side of the table, that'll probably be even easier. So however you gotta do this. And as we talked about, guys, earlier, there's a ribbon cable here that goes down, so be careful with that. That will plug in into that slot there. So we're not gonna tighten this yet, because we do need to start the other side also. Just run them down. And the same thing here. So if your x-axis is all the way down, like mine is, you can go ahead and tighten these. So snug them up pretty good, as these are the only bolts that hold the whole upper portion. And the reason I was saying the x-axis needs to be all the way down is because we want the separation between the 2 rails to be exactly where it needs to be on the bottom here. So yeah, if you're not all the way down, just run it down by moving the belt on the top. All right, so now we're gonna tighten the other side. And that should be good. So for the next part of the manual, they actually want us to install the hot end assembly, then connect all the cables, adjust the rollers on the bed, which we did already, and then the other rollers, which we'll go through, adjust the tensions on the belt, and then install the spool holder. And this bag of hardware here that has quite a few things, what appears to be part of the spool holder that we have to put together. And for the last part, we're gonna plug in the cable here, which we'll probably do that when we're connecting everything else. So yeah, I'm just gonna go through the printer. We're gonna go through everything, check everything, and connect everything as it needs to be. And so since we are looking here at the back, let's go ahead and connect these cables. So over here we got the Z motor connections coming out of the base. We can move the plate up so it's easier to get to. Yeah, so we're just gonna plug that in. Pretty simple. This cable here that's kind of sticking out from the back actually goes to this plug on top of the base. Now we do have this ribbon cable that we need to connect also, so you want to be really careful with that. And you guys can probably see the connectors on the other end. So be really careful not to damage those, because if you do, you will not get a good connection. And it's very easy to mess this thing up. So be very, very careful with this. So yeah, I'm just going to line it up here. I think that went down, and that should be good. And we'll try to tuck this wire here where it looks a little better. So it should be good there. So it does run underneath here and then go up, and the other end is actually also unplugged. Yeah, it plugs in right up here. There is some tape we need to peel off here to release it. I'll go ahead and expose these connectors. And so on this connector, we do have a little locker. See if we can zoom into it a little bit so you guys can see. There's like this little black piece that you gotta lift up, and then when you push it down, it locks it in. I'm gonna hold it up and then insert my cable, and it's gonna drop in there. And then to lock it in, we're just gonna push down on these tabs here on each side. Make sure you push on both sides, because when you push on one, the other one comes up. And that's it, that should lock it in. And that should be good right there. Again, be really careful with this, as you don't wanna, mess it up and have to use your extra cable. All right, so we plugged this in, the motor in here in the back. The ribbon cable's plugged in. Let's go ahead and go to the other motor, and we'll plug that in. And by the way, for some reason, all my motors are loose. Same thing for this side. I'm not sure if that's on purpose, but I'm thinking it's not supposed to be like that, so. And the bolts that do hold it down are Phillips, so you will need a Phillips screwdriver. And there we go, now they're not bouncing around. Maybe they just came loose from shipping. Same thing on this side. All right, now our motors are nice and solid. So we are pretty much done plugging everything in here on the bottom. There is one more plug on the top, and you guys can see it right here. And this is gonna be for the filament detector, this guy here, that will mount on the spool holder once we build it. So let's go ahead and do that. So the spool holder is not hard to put together. It's actually quite simple. We just got a washer, a bearing, and then a nut, and also install our filament detector. So let's grab our hardware. There's quite a bit, so put it somewhere we're not going to lose everything. So let's just start with this one here. You guys can see there's a couple threads coming out on each side, and this is where first we're going to put a brass washer and then a bearing, and then we're going to lock it all in with this self-locking nut. And the open-ended wrench, the smaller size, you can tighten it up with. But if you do have some tools like a socket, probably be a lot easier to do this. So don't tighten this hard, just a little bit snug, and that should be good. Make sure your roller is nice and rolly. Same thing for the other side. All right, and so that looks good on both sides. So let's go ahead and grab our detector, and this is what it looks like. So it does have to flow the right way, and I'm thinking it probably goes like this, as the spool will sit here and then feed down. So I'm just gonna go with that, and we can change it later if we need to. And you do wanna leave this loose. So there's a little tiny nut that goes on that thread, and there's actually two of them where you can kind of lock them together. So the detector is loose enough to move around, but not fall out. So now you will have to use your own tools to try to tighten these up because they're pretty tiny. That looks pretty good right there. So one half here is built. And for this side, it's pretty much just putting the wheels on. So I'm gonna go ahead and do that, and then we'll mount it on the top. And so looking at the back side of the printer, all the way here on top, the spool holder should mount something like this. So we're gonna mount it to the back side. If you do wanna center it up, there's actually this trim piece that's in the way. And I'm not sure why it's so long, but we can trim it to what we needed and then put it back in. And so these pieces here are gonna go to the inside like this. And we do have a bolt and a T-nut that we're gonna install here on the bracket. Two of them actually, just like that. And so wherever the center is gonna be, we're gonna insert the T-nuts into the grooves of the channel, and then we're just gonna turn the bolt and lock it in. And so the T-nut, as you're tightening it, should turn and then lock into the channel. So if it doesn't, just unscrew it and then screw it back in, and it should do it. This does sit right on top of the frame, so it should line up pretty good. And we'll do the same thing to this other bracket. All right, well, we got them installed, but we need to make sure that our spacing is correct. So we're gonna grab a full-size spool. And as you guys can see, I'm not even close. So we gotta bring them together. And plus I'm not centered right now, so this one here probably need to come over quite a bit. And I'll go ahead and adjust it here on the fly. So the bad thing about this is that, you know, if the spools are different sizes or different widths, you'd have to, you know, adjust this. And also another not so great thing maybe is that if you have like broken spool or a spool that can't roll and would rather do this, you know, this won't work either. But for, you know, most cases this would work. So yeah, our spool is on and it's rolling around just fine. And these are thin enough where you can bend them around if you need to, just a little bit, you know, if it's not lining up perfectly. So now we just need to figure out how long this little trim piece needs to be. Probably about to here. And I'm just gonna snip it off here. Make it a little shorter. That way we can still hold our wire in there nicely. But it can come out and go on the other side here. And I'm not gonna run it underneath because if our x-axis comes up, it's gonna be able to snag on it maybe. So I'm gonna run it towards the top. So the whole thing here is that you wanna keep it away from the belt. And I'm gonna use this other piece that was the leftover to hold it on top. And then we can flip around to the front. And maybe you guys can see this wire will plug straight into the filament detector. Yeah, that looks pretty good. So our filament is literally gonna go from the top and then down through the filament detector, just like that, and then into the hot end extruder. All right, so now that we did all that, let's go ahead and do something a little more fun and install one of these tool heads onto the dolly here. So there's a bolt here that keeps the head from coming off, and also there is a sticker here that we need to peel. But yeah, all these connections are just gonna connect to each other. And we should be able to just slide it in. And sure enough, there it goes. Okay, so the bolt actually goes through the back. And so that kind of clamps it down, and now it's not going anywhere. Very cool. So we do still need to adjust the belt and actually check all of our rollers here on the hot end and the sides. And so looking at the back, let's go ahead and check our rollers. So my printer here is adjusted perfectly, but yeah, you guys can see I'm just spinning the rollers in one spot and they spin pretty easy and it should feel smooth. I got some funny things going on because the belt still needs to be tightened. So we'll do that here in a second. But if you do need to adjust the eccentric nut, let's go ahead and raise this up a bit. And I'm just moving the belt on the top to go up and down. But yeah, you'll just adjust it from here, tighter or looser, and get it just right where the wheel can just spin in one spot like a little burnout. So yeah, that looks good here. Now on these, they're not super critical unless they're just really binding. On mine, they're actually perfect and they're all spinning and touching, which is quite interesting and not always the case. But yeah, if you do need to adjust them, the eccentric nuts are on the inside. We do have dual Z axes, so everything is really stable. And so if these are not perfect, it's not that big of a deal because they move so little. It's not gonna wear things out, and sometimes you just can't get these right no matter what you do. So if you got them close and nothing's really binding or really off, then you should be fine. So let's go back to the front. On this side here, we can see we got the belt tensioner or idler pulley, and our belt is completely loose. So we need to tighten that up. And in order to do that, you guys probably won't be able to see, but there are two bolts here that hold this bracket with the pulley on it. So we just need to loosen them. And then this bracket here will be free. You can see it just rides on that channel. And so what we're gonna do is we're just gonna pull on it just a little bit to get some tension. And then we'll tighten one bolt to see what it looks like. So it does look really good right there, and the belt is reasonably tight, so you don't want to over tighten the belts. Just slightly some tension, but not crazy tight. So since everything's good, we'll go lock in the other one, and that's it. Good with the adjustment here. The only other thing you might want to look at is the belt here, which is on the y-axis, and there's a pulley right here, and then on the other end we have the motor. You guys won't be able to see this, but the way you adjust the belt is the motor itself, and you can do that from underneath. So if you do need to adjust it, there's a couple bolts you loosen, and then you move the motor back and forth to put the tension on the belt. On my printer, it's just the right tightness, so I'm going to leave it just the way it is. And yeah, the bed feels pretty good overall and quite smooth. So I believe that is everything with the assembly. So yeah, not too hard, guys. There is a little bit of involvement here, a little bit of assembly for the spool holder. The ribbon cable is a little fragile, so be very careful with that. And overall, just go around the printer and check all the bolts and all the rollers and whatnot else, just to make sure everything is buttoned up and nice and tight. So I am pretty excited to power this thing on, but before we do that, let's take a closer look at all the details. All right, so this is what the printer looks like just sitting on the desk. It is quite large and very tall with the spool holder and the spool on top of it. So yeah, just keep that in mind that you will need the space for it. All right, so starting here on top, you guys can see how the spool holder holds the spool. Not my favorite kind of spool holder, I guess, but it does work, and I do like that it rolls on bearings, which makes it very smooth. And here we can see our filament detector that kind of swivels back and forth, and it seems to line up just right with the filament. Flipping the printer to the back side, we can see here what it looks on the back. Spool holder mounted on these 4 bolts. You guys can see the covers, and then another little cover here to hold the wire and goes to the detector. So yeah, it turned out very nice and clean. So this is our synchronization belt between the 2 leads. Everything is metal, very nice, with bearings for the leads. Going down from there, I like the construction of everything. It's all metal, and we have a brass bushing, but this piece here, the spacer, is actually 3D printed, which is fine because it doesn't really do much, but we do have little bolts there that go into the print. So going down from there, we can see we got the coupler here with the motor, and then the connection does use a plastic bracket, which we did have to tighten those little bolts on top, stop the motor from moving around. We can see our plugs that we plugged in, one down here, then the motor, and then the ribbon cable on the front side. Now what's awesome is we get really large rails for the Y and the X. Very nice and impressive to see that. You guys can see that's the Y motor, and it does move back and forth to tighten the belt, and you loosen 2 bolts underneath to do that. Going back here to the top on our hot end, this bolt here locks in the tool head, and it's a little bit hard to get to as it's kind of like doesn't have much grip. I wish it was a little longer maybe so you could reach it better, but not too bad. So our rollers here nicely adjusted. Going down, we can see this really cool design on the base. We've got these cutouts, very interesting and very unique looking. So going all the way down, you guys can see we've got a pretty thin profile. Very impressive for how large this printer is. And again, I love this. It looks like cast maybe, because I don't know how they do all these corners all in one piece, because the whole thing is pretty nice looking. So it's probably stamped, but in any case, it's very nicely designed with very clean construction because it's all one piece. But yeah, here we have the input port for the power cable. It is fused with an on and off switch. And from the back, we got a cable that comes out and goes to the bed. Now I can't really tell if it's strain relieved or not, but there's some kind of glue around it or rubber, but it seems like somewhat it is. And you guys can see that our bed is insulated, which is great. So let's go back to the front. In this corner here, we can see there's a nice little accent, and the theme of the printer is like an orange. So yeah, it looks really nice. So we got a junction box behind there. It's our X-axis motor. And yeah, everything nicely organized. And our ribbon cable does come from here all around to the hot end, and the other side plugs out of the junction box, loops around and goes down. And this is where we plugged it in. So yeah, on top here we can see the dual gear drive extruder. So we already kind of looked at this earlier, but yeah, very nicely designed. I love this little cover here with the Tevoup logo. Our heat brake fan here with the round style heat brake, heat block. Yeah, everything seems to be nicely built and put together. And we also have a very large parts cooling fan that blows under the nozzle. And also guys, we do have a clear, looks like BL Touch style leveling sensor there, and you can see the probe coming out. We got a very large volume of 305 by 305 and 400 millimeters tall. There's a sticker here on top that kind of tells us about how to install the ribbon cable like we did earlier. So yeah, make sure you pay attention to that. But we do have a protector here over the bed. Let's go ahead and peel that. So the bed itself is a perforated kind of finish. When the bed is hot, the models stick, and when it cools off, they should just pop right off. So yeah, we'll see how well that works. And going down, we saw that it is insulated. And what's great, it's all the way to the edges, which is going to do really nice and preheating our build platform quickly. And this is an AC bed, guys, and that's that little orange rubber that you see there. That's the heating element. So the frame does appear to be pretty good quality, and we get these nice little orange knobs to adjust the bed. There's some numbers on them and nice quality yellow springs. And on the front, we got the logo here and the screen, which has a protector. Let's go ahead and peel that. That came off pretty easy. The screen is not too large, 2.8 inch, but you know, it should be good enough to navigate the printer. On the right side, we got micro SD card input port, USB port for the thumb drive, and another port to connect to your computer from the printer with the cable that came with it. And on this side here, it's pretty clean. Nothing going on too much here. And also our laser head attachment, we'll also try out once we get it all going and printing. So yeah, overall, a very interesting and unique looking printer. I do love the design of it. It's quite unique looking and very futuristic. So for the next part, let's go ahead and power it on, home the printer, preheat it, and level the bed. All right, so I got the printer plugged in. Let's go ahead and power it on, and I got you guys looking from the top down. Hopefully you'll be able to see the screen there. All right, so it beeped, and the screen is lighting up. Got the logo there. And there it goes. So I got pretty bright lights in here right now, and the screen is a little bit brighter than it actually looks. But to be honest, it is more on the dimmer side. And if you guys can see, the language is actually set to Chinese maybe. Let's see if we can't figure out how to change that to English. So let's click on this settings button. Okay, so I'm thinking this is it here. So yeah, these are all the available languages. You just need to click English and then back. And now we can read everything. So yeah, in the main menu here, we got tools, settings, and printing, and then our nozzle and bed temperature on the bottom. So if we click on tools, we're gonna get preheat, extrusion, move, home, leveling, filament, and more. So let's click on more. It says G code. That's interesting. I guess you can have a specific G code for whatever reason. So yeah, let's go ahead and hit preheat. And they do have ABS PLA here. So let's click on PLA. So let's see, how do you get this thing going? I see it says, oh, okay. So it appears if you click on the ABS button here that does not look like a button, it actually starts preheating, or PLA. So it goes to 200 on the nozzle and 60 on the bed. So, and this is where we're gonna toggle between the two. Very nice that they have preheat buttons there. And I don't know if you guys can see, but the touchscreen is attracting fingerprints really easy. But yeah, this is your typical nozzle and bed temperature controls. Extrusion is gonna run the extruder motor to bring filament in or out. Move. This is going to move individual axes a certain amount. Home, which I'm going to go ahead and click. You can either home all or individual axes, but they also have a motor off just for X and Y and not the Z. So I'm going back. We got a leveling button, which we'll come back to. Filament, where we can load and unload. I guess that's the same thing as extrusion, but you just got a little more options here. But that's pretty much for the tools menu. Let's go to settings. So we got EEPROM set, fan controls, about the printer, UI switching, and this is quite important as this is going to go from 3D printing to a laser engraving, and we'll get into that once we change our tool head and try the laser. Configuration, so we got machine settings, motor settings, leveling settings, and advanced settings. And I'm not going to go through all this, but yeah, this is what's available. We got the language as we saw earlier, Wi-Fi capabilities, so it looks like they have a cloud option, and yeah, you can connect to Wi-Fi. And it's actually pulling up my Wi-Fi here. So yeah, you do have these options. But yeah, that's pretty much it for this. And then you got the printing button that will read the SD card or the USB drive to print the prints. And that's pretty much it for the menu, guys. So you guys probably won't see the screen too well, but I'm gonna go ahead and click on tools, then home and home all. So we're gonna check, make sure all of our axes work. All right, so we got the X, the Y, and the Z, and I did hear the little probe there come out, and it looks like that's working too. And it does appear that we have some kind of optical sensing for the X and Y end stop switches, and our Z is the probe itself. So yeah, it looks like everything is working. Our bed is hot at 60 and the hot end is preheated at 200. So the next thing we need to do is adjust the bed, and then after that we'll let the automatic bed leveling do the probing and the offsets. So we'll go back to tools and we'll click on leveling, and hopefully you guys can see this. But I'm just going to explain it here. So we got point 1, 2, 3, 4, 5, and that's the different 4 corners in the center that we can manually go to. And then we also have the auto leveling button over here that once we're done with manually adjusting it, we'll click on that for the auto bed leveling. So it's quite important that you do the manual bed leveling first and then the auto bed leveling. So let's click on point 1. Okay, there it goes. And I'm just going to use this little post-it note to build my gap, and it looks like it's homing again. And you can use any kind of sheet of paper. This is pretty thin, but any normal, printing paper would be best. All right, so right off the bat, we're gonna have to cut it loose quite a bit here because we have a large gap. So yeah, we're just doing normal manual bed leveling, and we got the assistant here to go through the corners. Okay, now we're way too tight here. This one didn't need too much. But yeah, guys, we're just gonna go around and round and round until we get it pretty close. So about 2 or 3 times. You don't have to get it perfect, but pretty close. And as you adjust one corner, the other one will change quite a bit. So definitely go at least a few times around. So yeah, I'm getting pretty close where, it's pretty micro adjusting at this point. So as long as you're relatively close, the outer bed leveling will compensate for the rest. So now we do have 0.5, which goes to the middle here. And this step is not really necessary because outer bed leveling should compensate for it. And we can just adjust the Z-axis offset when it's done. So let's go ahead and click on outer leveling. And that's gonna use the probe to probe through the whole bed. So it looks like it's taking 3 by 3 measurements. Yep, so that's 9 total. I would have liked to see 4 by 4, but I guess this should be fine. All right, and that's our last point. And so now a new menu pops up for our Z-axis offset. Let's go ahead and use this paper here after it's ready to go down. So it's doing a measurement at this point, and now I think it should be going down. And there we go. And so we got a pretty good gap that we need to go down with. So let's go ahead and click the minus Z offset. And you can change the parameter here. We're on 0.01 at a time, which is pretty fine micro adjustment. I'm going to change that to 0.05. Okay, there we go. So we got tighter. I'm going to change that back to 0.01 and go up just a little bit. Still too tight. Too tight. And since I'm using a really thin sheet, I want to make sure mine's not too tight here. So, and I think that's pretty good here. So, and we are preheated still, 200 on the nozzle and 60 on the bed. Now all we got to do is not to forget to click on save. So let's do that, and that should save everything that it just did, and we should be good with the auto bed level. All right, so let's go ahead and bring up the Z-axis a little bit so we can bring our filament in, and we'll go ahead and push that through. So all you gotta do is pull on this knob here, and then we can feed the filament through all the way down. Now in a setup like this, it's easy just to push it through yourself, but I wanna go ahead and show you, if you unscrew this little knob here, and this is how you adjust the tension, you guys can see the dual gear drive extruder and our filament there. It's a little bit hard to get it just right, but once you do, it does go all the way through, and you guys can see we are purging out the other end. So yeah, since this is not much pushing, this is the fastest and easiest way, but you can use the touchscreen to push it through also with the motor. And on this knob, when you put it back, there's a spring here. You don't want to tighten it much, just a little bit. Since there's 2 gears that are around the filament and they're both going to be pushing, you don't need much pressure to get nice consistent feed. So yeah, we're pretty much ready to print. So let's grab our thumb drive and see if there's anything on it. So we're going to plug it in right here on top. And it does glow a little red light. So let's go to our menu, click on printing, click on USB drive. So we got a G code for printing, and then we got a couple laser files, and then a few folders here, which we'll check out once we go to the computer. But let's go ahead and do this G code test file that's included with the printer. I'll remove these little buggers here. We'll click on that and then confirm, and it starts. So I'm gonna click on options and see if we can adjust baby steps. Yes, we can. So I'm gonna go ahead and get that ready. So when it starts, I can go up and down, depending if it needs to or not. Hopefully our offset is good. Okay, so it's going to do bed leveling, I guess, from the beginning of each print, or at least that's what it's doing. But since there's only 9 probes, that shouldn't take, much time. All right, so it looks like it's going to printing. And I think our offset is good. Yeah, it is. It's actually perfect. So yeah, it looks like our leveling was just right. Let's see. It might be a little too close. I'm gonna go up just a little bit. It does feel like it's maybe a little lower than I would want. So yeah, since I was using a thinner sheet, I probably should have been a little bit more off, but we do have the baby steps here and we can adjust that on the fly. But yeah, that was pretty simple. All right, so let's take a closer look at the screen here as we're printing. So we got like a little preview that's like a standard box. Depending on the software, that could be showing the preview of the model. So we got the percentage bar, which is at 4%. The time since we started. The Z-axis location at the moment, just 0.66. The nozzle temperature and the target, also the bed and the target. And also we do have a little fan here. It's just 0 right now for the parts cooling. Normally prints are sliced where the fan turns on after a few layers. Then down here we got pause, stop, and options. So here we can adjust the temperature and you can go up and down and you can actually change it to the heat plate right from here. You got filament, so if you want to change your filament while you're printing, you could do that. The fan controls, you can manually adjust it here. So here we have some kind of power options. Okay, so it's got manual and auto. So let's turn that on and see what happens. Then we got speed, so you can adjust how quick extrusion is, or the movements, you can toggle that here. And then we got baby steps, which we used, and I did go up 2 times on the 0.05, which makes it 0.1. But yeah, that's pretty much all the controls, and yeah, very nicely laid out, and I like the overall clean UI. The only thing is that the screen seems to be very fingerprinty, so whenever I push it, I leave fingerprints and smudges all over it. So the printer is pretty quiet overall. There's not much sound from motors, but there is a little bit of fan sound. And I'm going to bring my microphone in so you guys can hear it. So most of the sound is coming from fans, and yeah, very happy with how the motors sound, but overall this is definitely on the quieter side. So we're about 9% in on this print, and it's been about 10 minutes. So we're gonna let this thing print out and see what turns out. All right, so the cube's already done, and it only took 32 minutes and 29 seconds. So let's confirm that, and it goes back to the main menu. All right, well, the bed is actually still hot, but I bet you whenever it cools off, this should just pop right off. Well, let's see how easy it is to peel it while it's hot. Okay, so it is peeling, but it is stuck on there really well. But it does pop off pretty easily also. So I'm pretty sure that whenever it cools off, it's gonna just come right off. So there is a raft that looks like comes off pretty easy. Very nice. So this was printed pretty quickly. It's kind of hard to see on this red filament, but it turned out pretty good. So we got the X-axis, and I think that might be our Z seam right there. We do have a little bit of vibrations, and this is our Y-axis, a little more vibrations. Yeah, not perfect, but not bad either. It was printing really quick. This is what the bottom looks like, and on the top we got a little Tevoup up a logo there. So yeah, not bad overall. Pretty happy with this start. I think if we slow down a bit, it would definitely look a little better on the vibrations, and maybe we do need to adjust our belts a little. Well, honestly, mine feel pretty good. I am happy with the tension on that, and the Y is a little bit tight. Maybe could be loosened a bit, but you know, this is a pretty large glass bed. Yeah, I think we just need to slow down a bit to get better results. I think for the next part, let's jump to the computer, check out what's on this thumb drive, and slice our own print. All right, guys, so we're at the computer, and I got the thumb drive plugged in. Let's go ahead and open it up, and this is what we see. So we got a few folders here, G-codes, and a PDF. So on this first one here, looks like we got another G-code of this thing right here. It's like a model of some sort. Not sure exactly what this is for, but maybe this is some kind of add-on or something. In any case, here we have some other folder, which includes a machine settings document and a Cura profile. So here they kind of go over how to use the slicer, which is Cura. It looks like here they show you how to do everything from scratch, which is good. And then you can import the Cura file or profile that they give you and try that out, and that'll set you up. Now, for me, I think we're just gonna build our own, as I try to use my standard settings for all the printers. So here we have the software. Looks like a laser GRBL program for Windows, a light burn project, also a light burn program, and the Cura slicer installation program also. So I don't use Windows, so most of this stuff here is useless, but if you do use Windows, these could be pretty helpful. Now, if you're on Mac like me, you can just go to ultimaker.com or just search Cura and you can download it straight from there, which they have a compatible Mac version. So here we have 3 test codes that were included. We printed out the little cube G code, and we also have a couple laser laser tests here. And most likely this is all I'm going to do with the laser for this video, as I would need to find something that either works with Mac or find a Windows computer to even run the laser program. For the last thing, we have a PDF of the manual, which is basically the same thing you get as a hard copy, but in digital form. So it could be pretty good to go over and kind of learn about the machine. And these are actually all the parameters. And we can see here in the laser parameters that we have a 5500 milliwatt, which is about 5.5 watt of power. And the compatible software is Lightburn or Laser GRBL. And also in the manual, they do kind of go over of how to use those programs to engrave and use the laser. So yeah, that's pretty much everything here. Let's go ahead and open Cura, and we'll just build a new profile. I'm going to click on add printer. We're going to click on non-network printers. So instead of doing custom from scratch, I'm just going to pick something from Creality that's similar to this printer. Or actually, I'll just use an Ender 3 Pro profile, as I'm pretty familiar with it. And we can rename it to Hydra. Add. Here we're going to put in our machine settings. Just 305 at 305, 400 tall. So everything looks good. The only thing I think we need to add is next to the G28, we'll add G29. And that's for the out of bed leveling sensor. And that should be all we need to do here. So let's click on next. And you guys can see our build volume. Now you don't have to do it like this. You can, go by the manual and install the Cura profile, which is pretty simple. If you click on the printer and then manage printers, over here you can see profiles. If you click on that, you can import a profile. And you guys can see the Hydra profile comes up. And you just open it and it just appears in your profiles. But when I import it, it doesn't work because it only works with the custom profile. So if you have the custom one open, it will import and then you can use it. So in any case, let's throw something in there. Let's do a benchy here. So if you click on the model, you can move it by just dragging it around, or you can drag it around by these arrows. So let's go ahead and just push it back. Or here on the side, you guys can see we have some controls. So we're on the move, and you can type it in here in millimeters and it'll move that certain amount on the axis. We also have scale. Again, we can drag it around, or we can put in the parameters here in percentage or actual millimeters, and rotate, where we can move this direction we want. That's pretty much your basic controls. Now, what we really need to do is set up our profile here. This could be preferenced, depending on how you like to print and things like that. But I'm just going to go over really quick of how I do it and how I test most printers, because, the functionality is pretty much the same on all of them. We just have variables like direct drive and whatnot else. So for layer height, 0.2 is good. On the shell, I like to change the wall line count to 3, as it does make better walls. And also the top layers to 5, and that minimizes gaps. Fill gaps, I'm going to turn to nowhere, as I like to see where they are. For the infill, 20% is pretty good. For most things, you can go up or down depending on what you're printing. Temperature 200 and 60 on the bed, we'll leave that. And I'm going to leave the print speed at 50, except for change the initial layer to 15, but the skirt and brim will do 25. Now here's something that we do need to change. We have retractions under travel, and since this is a direct drive extruder, let's just go ahead and do 1 millimeter retraction instead of the 6.5 that was in there. And the speed we need to bump up to probably like 45 to 50. So let's just do 50 for this one, as the extruder is geared on this one. Combing mode, not in skin, is good. So everything else looks pretty good. Cooling. If you want to use supports, this is where you're going to check this and then set your parameters. Build adhesion is skirt, and that's basically 3 lines around the print and then it starts printing it. So you can change that to brim, which will basically print straight to the model and then out, kind of make a big footprint, just 1 layer around the print to help it hold to the bed. So if you have problems sticking, this could help. And then we got Raft, prints basically a whole raft underneath the model and then prints the model on top of that. I normally don't like using this. It wastes a lot of time and also material. So skirt is what I prefer, printing straight to the bed. So everything else looks good. We also have spiralized mode here, which we will try out. And that's just going to be a couple layers on the bottom and then 1 layer all the way around to the top. And we'll see how that does. But yeah, that's pretty much it, guys. So if we click the slice button here on the bottom, it's going to slice it. It says 1 hour and 54 minutes to print this print. So here we have a preview button. If we click that, it'll show us the preview. Let me change this here. Of every layer, or whatever layer you want to see. And if you push play, it'll actually kind of virtually play that out, each of the layers. So, and you can speed that up if you want. So this could be pretty good if you're, trying to model up something and want to see how it'll print in that area. But yeah, all we got to do now is click to save to removable drive. Since we have our thumb drive plugged in, it will go straight to that. And we can eject it straight from here, but we're not going to do that yet. And up here, I'm going to click back to prepare to go back to normal view. I'm going to double click, clear the build plate, or right click. and drop in a calibration cube. Also push that back a bit, and we'll go ahead and slice this cube exactly the same way, and we'll save it to the removable, and we can inject our thumb drive straight from here by clicking eject. And yeah, that's pretty much it. So hopefully this little quick overview was helpful, and if you want to learn more about the Cure Slicer, there's a lot of great videos out there, so yeah, check those out. Alright, so we got the Benchy and the cube printed out, and the printer's having no issues and everything is working as should. The prints are sticking and popping off quite easy after it cools off. So let's look at the cube first. So here we can see the X. There is a little bit of vibrations, but overall the layers are sitting really nice, and a tiny bit of ghosting you guys can see there, but not a crazy amount, so not too bad on the X. So here we have the Y, also very nice. A little bit of ringing and a small amount of ghosting also on the Y, but very minor again, so pretty good there. We got the X wall and the Y wall. The bottom looks great, and the top. So yeah, it did extremely well with the cube, and I'm quite happy with the results. So the Benchy is still stuck to the plate. Let's see how easy it breaks off. And look at that, it was still stuck, but as you guys saw there, it comes off really easily. And that's what's great about these perforated style beds, is when they're hot, the print does stick to them, and when they cool off, they just pop right off. So the Benchy turned out actually much better than I would have anticipated. But yeah, we can see the bottom, very nice. The side walls, very good. And depending on the lighting, sometimes you can see those lines and not, but overall, if you look at the reflection, you can see it's really even. Overall, layers are sitting beautifully. There is something a little bit right here, kind of going down. It's got an artifact, but nothing bad. It looks great, honestly. Not much ghosting at all around here. Again, that artifact right there. This is our Z seam. Yeah, very nicely laid down, guys. Really impressive. So we had a little bit of stringing, not bad at all. And this was at 1mm retraction, so it looks like that's about the sweet spot for this guy. And this filament is naturally a little bit stringy, so it should do pretty well with better filaments. But yeah, we can see the box. It's got that slit in there, and that's because we're not filling the gaps. On the back, we can see the wall there has a little bit of vibration, and that's on the Y. This is a pretty large glass bed, so it will have a little bit of that. Cooling seems very reasonable also. And yeah, the top also looks great. And overall, just a pretty solid, nice print that came out. So yeah, I'm really happy of how this thing is printing from the start here, and pretty confident that it's going to do great on anything we print on here. But before we do print anything more, what I want to do is try out the laser, because we do have a couple test files for the laser, and I'm thinking we should go ahead and see how that works. And if you guys remember, you do have to shut off the printer before you change your tool head. So let's go ahead and do that. And we'll pull out this filament, remove these prints here. But yeah, it's as simple as twisting the little locking knob in the back, just enough to release the tool head, and then we can just go straight up. And look at that, simple as that. We got the printing hot end extruder assembly off just by sliding it. And that's super cool, because changing it to laser is quick, and we're just gonna slide in the same way we slid out, and then lock in the back, snug it, and there we go. Now we got the laser. So we do have this little cap here, and I think, I'll peel off this protector. This is just for the light not to, you know, spread too much as it's lasering. So I believe it goes like this, but I'm not too sure exactly. Let's just leave it like that, and we'll power the printer back on. So if you guys remember, we do need to change the operating system to laser, because we're on 3D printing right now. And that's gonna be in the settings, UI switching, and we'll click on engraving. And so instead of print, it says engraving now on choosing the files. So let's go ahead and grab this piece of steel sheet that was included, and we're gonna put it over our build plate to protect it. And we're gonna grab these clamps that were included. And the glue stick is for 3D printing if your models are not sticking, but you know, we're not having trouble at all with that. But yeah, these clamps just clamp around the sheet. Probably need to go back in front. Not sure if we need all four, but I'm just gonna go ahead and install them just in case, so nothing moves around. Now don't forget, guys, we do have these glasses that are kind of red tinted. You do want to wear these because if you're going to look at the laser beam, you want to have some protection for your eyes. So out of curiosity, let's click on engraving, thumb drive, and we'll click on one of the laser files that were included and see what happens. So the file is called laser test deer, and then it's giving us a few options here to choose from. Let's just click on border and see what happens. And I'm just going to be shooting at this steel reflective plate, so it shouldn't do much, but I guess we'll find out here in a second. Yeah, let's click on border, see what it does. All right, so that looks like it doesn't do anything. So let's click on graphic. Okay, there we go. Yeah. I guess depending on the kind of file that was. So now it's burning into the sheet, but it's actually not doing anything. It's just reflecting. Z-axis didn't go up and down, so I'm thinking that we're doing this all wrong, and maybe we'll have to set the distance first before we do anything else. I'm gonna go ahead and cancel this because we're not doing much. All right, so yeah, this is what happens when you don't read the manual, but yeah, it says that we need to bring the whole laser down about 2 to 3 millimeters from this acrylic piece to the build plate, and that should be pretty focused in. So let's click on tools, and actually guys, we get a whole new menu here. That makes sense because we changed the UI. So we got a home, positioning, move, power. Okay, so you can control the power level of the laser. You can turn the laser on slightly, on and off there, to see where your position is, I guess. And here we have a positioning button. Okay, so the positioning button sets where the laser head is as the starting point. And if we click on home, I guess we can home it from here. So as you guys can tell, I'm not very familiar with lasers, as I've only used a laser once before a while back. So I do apologize, as this is a little new to me also. Okay, so I think what we need to do, or at least the fastest thing to do, under the home, we'll turn off the motors so we can move them around. Okay, great. And we'll kind of go to the center of the bed as our starting point. And I'm just going to manually let down the x-axis, or should I say the z. And we're looking for about 2 to 3 millimeters there. You know, slightly above the build plate, or whatever we're burning into. So if we turn on the light, we can see where it's going to start, exactly on that little point. Hopefully you guys can see most of this stuff. So I'm going to go ahead and run a test here again to see what happens. So let's click on engraving on graphics. And there it goes. So it kind of moved a little bit to the side and started engraving. So it does appear that we are definitely much more reaction going on now, since we're much more focused, I guess, of where we need to be. Also, the starting position appears to be like a corner. So maybe we should position the laser more in this area here, as it does seem to be like the front right. So it depends, I guess, how it was sliced in the program, you know, if it's off the center or off an edge. But this one appears to be off the edge because it just kind of went to the side and started printing in this area. So, or should I say engraving. All right, so I'm feeling pretty confident in this little test run here that we can go ahead and burn something into this piece of wood that they gave us to try on. So I'm going to stop it. And it looks like we do need to go up a little bit. I'm going to use these clamps here on the edge to clamp the wood down. And we'll actually just set the position. Hopefully this is going to be good right on the edge. So if we do mess up, we still have the other side of the board to try on. So I'm just going to go ahead and YOLO this thing and see what happens. So let's go for it. Graphics. And there we go. So we are actually burning into the wood and creating a little bit of smoke. So yeah, if you got a smoke alarm, you might want to, you know, watch out for that. It probably will go off. Or actually, guys, it almost looks like it's cutting because it's going over the same shape over again. So yeah, I do believe we are actually cutting. All right, so it actually started something new farther down. So yeah, guys, I'm pretty sure we are cutting and not engraving, but yeah, it looks pretty cool. Hopefully we started it correctly, because if we didn't, we probably messed up our whole board there. But yeah, I'm just gonna let this thing engrave out. We are at 12%, so it looks like more to go. I have a feeling maybe we will be off on some of it, but in any case, we'll be able to see what comes out. Alright, so it's done cutting and now it's doing some kind of engraving, kind of like, I guess, a picture or some kind of light engraving on top of the pieces it just cut out. It's quite a bit of smoke right now, so it's really heavily engraving. And we are at 94%, which is really close to finish. So I guess it's putting the final touches on the project. All right. And it went back to the start position where we started. And now that it's done, we can see what it was doing. So it's looks like some kind of animal with legs and pieces that connect together. By the way, it did take 30 minutes and 25 seconds, I guess. Oh wow, look at that. We actually burned into the... Oh wait, no, we did not. That's just residue from the wood. Okay, so we did cut all the way through and the pieces are all just falling out. Look at that. Wow. That went as planned and it cut right through this thickness here. This is a deer, looks like, that comes together somehow. We do have some antlers here in pieces. Let's see if we can't figure this out. So I believe that goes there, and our antlers should go here somewhere, I think. I guess something like that, maybe. And then we got the legs. So yeah, it looks like we got it together pretty quick. It looks pretty awesome, actually. And this platform here is where it'll stand into. So it kind of inserts in there. Doesn't really hold it, so you probably need to glue it. So it was a double function of cutting and also engraving. Very cool. See if we can get it to stand on its own here. But yeah, you guys can see, you know, you can make pretty good projects with a laser. Now it does look like we kind of messed up this board here, so there's only a little bit of area left. I might engrave something in here or maybe try to cut something out. In any case, you guys get to see the laser does work. And you know, if you are interested in lasers, this might be a good way to get into it and kind of mess around with it, as you have a whole 3D printer with a laser functionality. So for the next part, I'm going to print out more models, maybe use the laser, not too sure. And also I'll give you my final thoughts on this printer. Alright, so yeah, these are all the prints that I printed, and I actually did a little more lasering. And overall, I'll have to say, guys, this is a pretty unique printer. Now, not everything was perfect, and we'll talk about that in a second. So we've seen the benchies, we've seen the little red cube that came with the printer. So let's check out this little frog here. So overall, all the prints did turn out good, and I did print them at 0.2 layer height, 200 on the nozzle, 60 on the bed. The bed stuck well every time and popped right off, so really happy about that. And if we look underneath here, we got some weird artifacts and sagging. I'm not sure what that's about, but overall the layers do sit pretty good on this little frog. And this is a pretty detailed print. There's a lot of, you know, moving around retractions here on the bottom especially, and it did a really good job. And seems to be pretty good here on the cooling too. No stringing on the top at 1 millimeter. Now we do have some vibrations throughout the print, and you guys probably can see that. And that pretty much carries on through all the prints. So if I would have to say anything, is that there is some vibrations. Now we do have a really large bed, and it is a direct drive extruder. Yeah, there's a lot of weight moving around on the X and Y. Now this other benchy here that's in yellow, this is actually printed in TPU. I used the same profile as this first benchy. I just slowed it down to 70%. And this is what we got. Now we do have a little bit more stringing, but as far as the layers, you guys can see they're sitting really good, and you can see by the reflection there. And this is TPU. If I smash it here, you guys can see. So yeah, not too bad, and dialing in the settings could get that more perfected. Now another print I printed, which was a benchmark, and this is a very hard print to print, at least at its original scale. And this is an engine by a creator called Sunshine. He made this thing as a benchmark. I normally don't print these out because I have little success, especially with printers out of the box, and it was kind of the same here. So everything fused together, and I was not able to break this engine loose. So it is functional. It's supposed to spin. It kind of fused in multiple places. I think if I tried, I might be able to get it loose, but most likely I'd break it also. But I wanted you guys to see what it looks like in its original form here. Now if you scale it up, I think it would do much better, and maybe in the future I will try to scale it up and see what happens. So here we have a print called Gear, and this is a functional print also. So you got all these little gears that print separately. This should spin, and it doesn't spin right off the bat. I do have my Allen wrench here, and let's see how that goes in. Oh wow, that's perfect. So let's see how easy it breaks loose. Oh wow, that was really easy. Perfect, literally, look at that. Very impressive. All right, well, it did really good with this, and I wasn't expecting that. But yeah, this just shows the accuracy of the printer and how well the layers, you know, go down symmetrically. Because if anything is off, you know, you could have kind of a wobbly operation or it just fuses together. But here we have really smooth operation, guys. And this is our bottom, and you guys can see the bed leaves a really nice finish and sticks really good, and then pops right off when it's finished. So yeah, as far as accuracy, looks like this printer does a great job, and you can print functional prints. Now before we go to our last print, which is the spaceship in spiralized mode, let's go ahead and look at this other file that was included with the printer that uses the laser. And so here on the top, you guys can see this is like a sheet of paper, basically, or just regular printing paper that you normally print on, and it was definitely too thin. I didn't think about turning down the power, but even on this thin page, the laser actually did a pretty good job on a sheet of paper. Now below the paper, I actually used the rest of the wood that I could get. You guys can see, kind of had to use what I had, but this is the other file that was included with the printer, and this is what it made. So it's like a little benchmark of circles, squares, and millimeters. Also some burn marks here, and then a whole picture of this tiger. Looks pretty cool. Let's see if I can get closer. You guys can see the resolution is quite nice on this thing. So I was really impressed with how well it was able to burn that. And also we got a little bear there. So yeah, it cut and burned on this piece also. Yeah, the laser, guys, is quite impressive on this printer. And like I mentioned earlier, I'm not really familiar with lasers, and it definitely would be fun to do some projects. Now you would have to get some kind of wood if you do want to do like cutting and stuff. I think this wood here, and this is the deer that we built earlier, I actually super glued him to this thing so it doesn't fall apart. And I'm not sure if the antlers go that way or which way, but I think I had them wrong maybe last time. Yeah, this wood is really like thin. I wouldn't say thin, I mean like really low density, I guess is the word I'm looking for. So it's not too hard to laser through. Now I think you can find these things either online somewhere or maybe like hobby shops, which there's a lot of really great projects out there for the laser. So really cool and really fun with that. So yeah, I really like how the laser is included with this package, which gives you a lot more versatility. All right, so the last print we got here is the spaceship, and yeah, it didn't turn out great for a few reasons. Now it is still stuck to the bed, and let's see if we'll be able to take this out. Now because this is in spiralized mode, it is separating in some spots, so it might just all break. Well, let's see how easy it comes off. Oh wow, that was super easy. I literally just pushed on it and it all came off, so wow, that's great to see. But yeah, this is the spaceship, guys. So it is the full height of what this printer can print, 400 millimeters. It is quite tall, and we did have pretty big spread on the bed. The auto bed leveling did great, compensating. Everything was even, and again, the bottoms look perfect. So yeah, really happy with the bed. But if we go here and look at the sides, you guys can see we got a lot of vibrations, and it's throughout the whole print. But the layers are sitting really nice and even for the most part. There is a little bit of layering here. I can feel it. And actually, guys, our top just broke off. Yeah, we'll get to that in a second. But yeah, you can see all the vibration and artifacts, and actually lots of vibration around this G here, and maybe even ghosting looks like. And in this window we got vibrations a little bit, lots of vibration on this logo. So yeah, just kind of vibration is the main issue here. Now, another issue that popped up, and you guys can see this whole thing's broke. The higher it goes on the Z-axis, the more chance there is for this to be uneven just a little bit. And whenever we're in spiralized mode, even a little will break it loose like this. Yeah, and you can kind of see where it kind of just starts printing in the air after that. Now, this is nothing too serious to worry about unless, you know, you're going to print spiralized mode this tall, because this is more towards the top. You know, if you're going to print a normal print, that little bit, it won't matter because the print is solid. But in spiralized mode, it has to be absolutely perfect in order for it to work. There's very little deviation it can do. So yeah, and it's going to affect more on the wider parts than the smaller, narrower. And again, just ringing. But as far as layers, they're sitting really good. And if we go up this point here, layers are sitting very accurate is the plus, but the minus is for some reason we were not able to cool all the way to the ball. So there was like a little melt here. I'm not sure why. It seems like we have a pretty good parts cooling fan, but I think it's pointed a little too high and maybe needs to be redirected a bit. But yeah, overall I would say it did great. And also another thing to mention about the spiralized is it was able to do it. Most of these printers lately here are not able to do the spiralized mode because of the power resume function and the way it's integrated. So yeah, I guess it's a plus and a minus for this printer in spiralized mode. But yeah, overall guys, I'm really happy with this thing. I think it does the job. It feels pretty premium overall as far as build quality and the way it's put together. Everything is metal. Definitely the highlight of this printer is the interchangeable heads between laser and 3D printing. The printing head has all high quality parts with dual gear extruder that's direct driven. I love the cable management of how all the cables are routed around. Very clean. We have dual Z axis lead screws that are tethered on the top. We obviously get the laser head also. And this part here is pretty cool that you can just slide them out and they have connectors on the back. Now there is maybe some danger to that, as they do caution you a lot about turning the printer off before changing the heads, which makes sense because whenever you move this thing up, your pins change connections as you go up with it. So if you have your printer on and the wrong pins touch the wrong areas, that could be a problem. Definitely be careful with that, and could be, you know, something a little cumbersome if you don't pay attention. We got the filament detection here on top, but the spool holder up here, I would have to say that I don't really like it because as I was printing, some of my spools are a little wider and narrower than others, and some of them have larger and smaller lips, and these bearings are so small, you have to get it just right in order for it to roll right. So it's a little tedious, and I don't really like it. It's a great idea, but I think they should have made a wider track of rolling, or even have like just a rod that rolls, or double up the bearings. I guess that's a little bit of a con there. Now what's not a con is this build plate. It's large at 305 by 305 by 400 tall is how much we can print. Because it's AC heated, it heats up super fast. I mean, you can go from cold to ready to go in a minute, which is quite incredible. And also the coating, like we talked about earlier, is great. It works perfect. And it is also insulated, so the insulation doesn't look so great because it's kind of all bent on the edges there, but yeah, it seems to do the job for sure. And with the out of bed leveling, it makes it really easy to start your prints evenly every time. Now, the only thing that I noticed that maybe is not so great is that there's no way to remove the bed itself, or at least what I can tell. I think it's just connected together, all sandwiched. And so if you do need to replace this eventually, it might be, you know, something that is a little harder to do unless you replace just the whole thing. So I love the large channels also they use on the X and Y. I wish it had some kind of adjustments for the belts where you can, you know, have a knob for that. I do like the SD card and the thumb drive option. I actually really do like the display and the UI, how it's all set up and it's easy to use and read. Yeah, the whole design of the printer, you guys can see, quite modern and futuristic and somewhat alienish, I guess. But yeah, pretty cool printer overall. I think for the right person that's looking for this kind of combo and this build size with the ability to, you know, use the laser, this is a pretty good option here. So if you guys are interested in this printer, I'm going to have some links in the description. Check it out. And if you did enjoy this video, then hit that like button. If you want to see more videos like this and other things I do on this channel, stay tuned for more. And also check out my 3D printing playlist. I'm sure you'll find something interesting there. And if you guys stuck around to the end, I really do appreciate you watching. So as always, thanks for watching, and I'll catch you on the next one. Peace.